All right, HED 241, Biostatistics and Public Health, Section 15, Scattergram, sorry. Quick review, because you definitely need to understand some of these concepts to be able to understand this section. Correlation refers to the extent to which two variables are related across a group of participants. Basic correlation definition. Pearson's R, already covered this, is a statistic that concisely describes the degree of correlation between the two variables. Okay, it talks about the degree, how much correlation is there. Okay, so what is a scattergram? It's also known as a scatter diagram. Okay, it is a statistical drawing or figure that illustrates the correlation between two variables. This is not something you see a lot in research articles. It's usually used more when you run the data and you're looking at it and you're just trying to get an idea of what does it look like. It's really just like a visual representation, but since you usually put the exact results, you don't put the diagram in a research article. You can. All right, so let's look at an example. All right. Here you have students. You have math scores. You have their algebra grade. Okay. D, so this 1 is a D. Okay. C minus, C, B minus, B, A minus, A. Okay. So you're seeing higher math scores. Let's look at this. So here you have the lowest math score and the lowest algebra score. Low math, low algebra. Second lowest math score, second lowest algebra grade. Okay. It's a direct relationship, which is also known as a positive relationship. Remember that. Remember, so the direct, so when scores on variable 1, which is math scores, score on variable 2. So when the variable 1 goes down, you see variable 2 going down. Okay. Relationship between math score and algebra grade is perfect. Okay. So for every single person. So your R is 1. Your R squared, if you do 1 times 1, you get 1. So R squared, remember, can be converted to a percentage by multiplying it by 100. So that equals 100%. So that means that 100% of the variance in the algebra scores is accounted for by the variance in the math scores. 100%. The data in example 1 indicate the basic math scores are a perfect predictor of subsequent algebra grades. So what does it look like on a graph? This is it. Okay. So each of these dots, if you go back to that chart, okay, you would look and see that this is Joey's. He had a 4 on math score and a 1 as an algebra grade, or a D. Okay. 6 for June, 1.5 C minus. This one is Justin's, so on and so forth. Okay. You'll notice that it is straight line. Okay, so perfect direct relationship, that's what it looks like. Okay, so when a relationship is perfect, the dots follow a single straight line from the lower left to the upper right. Okay, so that's when it's a direct relationship from the lower left to the upper right. I would know that. Okay, let's look at example 2. Okay, Mike had a math score of 5 and an algebra grade of 3. So, you know, when you look at this, you would have thought he had, if he had a 5, he'd be in here, and he'd be in the 1 range still. So D, probably like a D plus maybe. But really, he's up here in the B range. So let's see. This dot represents Mike's score of a 5. Okay? So you still have a strong direct relationship. See, it's still moving in this direction from the bottom left to the upper right. Your R here would be 0.83. R squared is 0.69. So percent variance explained is 69%. So having even that 1 that is different, it is not following exactly the same, throws off your explained variance. Okay? Being completely realistic, it is rare that you find a perfect relationship in social behavioral sciences. By the way, public health is a social behavioral science. It very rarely happens. It is very rare. So if we said instead of math scores and algebra grade, we were saying that your college algebra grade and your biostatistics grade. Okay, it's very, 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 very unlikely that there's a perfect relationship for every single student who's ever taken it with us. Okay, very unlikely. It's possible that there is still, and I will say there is we have looked at this, there is a positive relationship, meaning that those of you who score high on college algebra traditionally score high in biostatistics. Those who score poorly in college algebra traditionally score low in biostatistics. However, are there some of you who maybe took college algebra your first semester and you really didn't care and you said, I need to make a D, I made a D, and keep going, and you come to biostats. It's in your major. Maybe you were taking college more seriously now, and you come in and you make an A or B, which is great. That's where you see it's usually not that perfect relationship. Okay, let's look at example 3. Okay, kind of glancing at these, you're going to see, right, they're kind of all over the place. So a high score here, low, high, low, okay, low. All right, let's see what this looks like. Okay, you still have some of this line, right? You can still see it, but it's not perfect. It's got a little bit more. So moderate strong direct relationship, R is 0.64, your R squared is 0.41, so your percent explained variance is 41%. Let's look at example 4. Now we're looking at cheerfulness score and depression score. So, strong inverse relationship. Okay, so as cheerfulness goes up, depression goes down. Makes sense, right? The happier we are, the less depressed we are. So you have a strong inverse relationship. So you notice now this is going from upper left to bottom right because it's an inverse relationship. So it's R is negative 0.79 because it is inverse. Your R squared is 0.62. Percent explained is 62%. Okay, let's go through a few concluding comments and kind of see if we can wrap all of it up and make it sense. And there's a lot of slides on this one, but I think most of them are pretty easy to follow. When the dots form a pattern that goes from the lower left to the upper right, the relationship is direct or positive. When the dots form a pattern that goes like that last one, the upper left to the lower right, it's negative or inverse. Okay. So if it follows a single straight line, it's perfect. It doesn't matter if it's negative, perfect, perfect, positive, perfect, positive, perfect, negative, perfect. Sorry about that. Okay. The greater the amount of scatter around the line, the weaker the relationship. Okay. So you always want to imagine this line, see where those dots fall. So there's a low positive correlation there. This one's negative, so it's a low negative correlation. This one, you just got a bunch of dots. There's no rhyme or reason. There's nothing going on there. That is no correlation. Chapter 15, questions. Make sure you review those, go through all this. If you have any questions, as always, please let me know.